Next, please. And talking about transparent displays, there are many different types of them out there. What we're talking about today is a display more than 80% transparency. It's built on glass. It can be integrated into glass. Next slide, please. Lumineq Displays has been making displays for rugged and extreme conditions for about 30 years. Non-transparent displays, matrix-based, monochrome, yellow on black, high contrast for extreme conditions going down to about 76 degrees Fahrenheit, up to plus several hundred. Vibration, humidity, and otherwise shock and other very extreme conditions. They're very durable and the technology is very proven. What we're doing now is we're taking them into a new kind of vista of applications, making them not non-transparent by keeping them the glass transparency that they inherently have. Next slide, please. Next slide, please. This is what we're talking about. It's built on glass. The picture you can see there, it's a demo in my hand, and I've taken the picture myself. We have this very same demo at our stand at 3045. I'll give you the number a bit later. Well, it says basically, seeing is believing with displays, so I urge you to come and have a look at the stand more than just believe all the pictures you see here. But that is what we're talking about, a piece of glass with content. And that is the paradigm shift I'll be talking a bit more about now. Next slide, please. When information matters, to us it's a rather important slogan. You could say it's a slogan, but it has a content that tells you that usually when a display is used, it is to give you critical information immediately, accurately, and in a very legible manner. But also, when you're looking at a display in a car dashboard, you're taking your eyes off what you should be looking at. If you're looking through a window at the road to see the speed, you look down, then you look up again. We do know that head-up displays are emerging, but there still is a need for a killer technology in types of head-up displays and glass integrated, dashboard integrated transparent displays. Next. So it calls for a visualization, the data you need immediately and accurately. Next slide, please. To make it more faster and accurate, we believe that integrating the in-line of sight visualization is the only means to do that. Because in that sense, you won't need to take your eyes off what you're looking through the window at, but you're at the same time receiving the data you need. Next, please. The biggest technical challenges when it comes to making these kind of really in the line of sight displays is the transparency. LCDs today can come up to about 15% transparent in the visual wavelengths, and that's full color, but it is not really transparent. If you go to OLEDs, they can go up to about 40–50% transparency, but they aren't yet at least available on the market. Next, please. Can we integrate the display into a windshield or a glass? Well, we have done demos and we have examples of how you can do it into a double curvature windshield of a bus. Many armored cars, they don't have double curvature windows, but all the same, it can be done. Next, please. The tactical challenge, what we're actually addressing here is, can we, next please, to combine real-time vision with sensor-fed data, information, whatever, from whatever it is. In the picture, you have a forest harvester. You can see the driver sitting behind him. In front of him, he has a big, spacious, well, not too spacious, but enough glass steering cubicle. He's got displays already. He's got cameras back and front to see what he's doing or what's in front of him, behind him. Also, he has a display in front of him telling you some status of the engine, the machinery, etc., etc. Now, to make it easier on him, instead of having to take his eyes off his work all the time when he needs data, next please, how about integrating some of that data in the window? Technically, this we can do. Next, please. If you approach it from a more aesthetic, this is going further and further away from extreme military conditions, I admit, but this is the aesthetic scene you could paint. Imagine a window in a residential dwelling. That window could also have some data integrated into it. See this not as a display that's transparent. Instead, see it as a window that can have content. Next, please. You can have a weather station. The direction, humidity, temperature, etc. With the proximity switch, it turns on when you come to it, it turns off when you go away. Next, thanks. Here's a bit more critical, not extreme conditions. On the contrary, the conditions are very well controlled, but it's in incubators for a nurse or a doctor to be able to have their hands on in a situation, at the same time seeing the patient, and also at the same time receiving the data that is necessary for the care she's taking. You can see where the present display is, where the temperature and humidity it is, meaning that if a doctor has their hands in the incubator, he has to look back and bend down to see the data, which you could have in front of your face, literally. Next, please. Getting a bit more extreme conditions can be cold, windy, and vibration, and long need for high brightness. The floor of a container crane in a harbor, where the operator is looking through the floor to see the train, the container being lifted or lowered or moved. Instead of having to look to the side, where he no doubt has displays also installed, he can see the weight, the distance up, the distance down, and also identification and where it should be placed. This is putting data in the line of sight. Next, please. And of course, a rather obvious application. This is a freestanding one we've made as a demo. We have it at the stand too. Extremely small spot size. We're talking about micron accuracy in the segments that are individually controlled. We can control the 7 segment numbers below. And in also context, which we are working on, we can move that crosshair across the surface by using illuminating and just turning off and on different segments. Next, please. So we come back to the display. For techno geeks, people wanting to know more about what's behind that technology, then a couple of words now. Next, please. It's called transparent thin film electroluminescence. Next, please. And it's easier sometimes to tell people what it isn't instead of what it is. It's been around for 30 years, yet nobody really remembers it because it's fallen out of favor for some reason or other. Thin film EL is very different to thick film EL. Thick film EL and powder EL are also electroluminescent display technologies, but they're not as durable, they're not as reliable, they're not as bright, and they will let you down. But the thin film electroluminescence is a whole different ballgame. It's inorganic. There's not an atom carbon in it. It's not an OLED, in other words. It's solid state. It's not an LCD. It doesn't have a backlight because it's an emissive technology. So what you see is illuminated. And it certainly isn't a projection through the glass, if you were thinking. Next, please. And next. All these not being gives you basically some unique properties. One of them is that after about 12 years, that's 100,000 hours, you still have 85% left of the brightness. 1 millisecond response time regardless of temperature. That is regardless if it's minus 76 degrees Fahrenheit or plus 200. But it also, for us, is an important opening in new business. It makes it possible to make more than 80% transparent display. And intrinsically, for the technology, humidity, shock, vibration, it's very resilient against that. Next, please. And speaking again, coming around to the term transparent displays, I can't beat around the bush. There are other technologies out there. They have found already some kind of niche business. LCDs, projection displays, they're not transparent, but they're used to give head-up displays today. Transparent OLEDs and transparent TFEL. None of these displays can give you the durability and the transparency of the TFEL, which is our technology, thin film electroluminescent displays. We can do them matrix and segment, and we do have both examples at the stand over there. Next, please. And with that picture, you can see actually I said we can do one color, yellow. Well, we can do green too. And we can do, as a non-transparent version, we can do a multicolor one, but the full color doesn't exist in this technology. We usually say you can have any color you want as long as it's yellow, and that usually works pretty well. But seeing is believing. To finish off, I'd urge you to come and see us at the stand 3045, where we got lots of transparent demos and also some of the non-transparent matrices. And let us tell you more about our technology. Thank you very much.
Yeah, hi, I got Larry Markowski from iPower. 2 questions. Is the display on the surface, and if so, what is the scratch resistance of the display material?
A good question. What starts is we start with the substrate, a glass surface, and thin film coating technology. We will put about 8 different thin films and etch in between to get the segments, etc. After that, it has to be covered by a cover glass. So the demos you see, and all the non-transparent ones, they are 2 sheets of glass. One on which the display is built or stacked, and then a laminated glass as a cover glass. And basically, when it's a non-transparent, you're actually looking on the base glass you built it onto. That's through which you're looking at the display, so it's in between the 2 glasses. The whole thickness of the entire stack is about 3 micrometers. 3 microns. So it's nanotechnology before the term was even coined, but there you go.
Are there any artifacts for the gauge structure and the types of outlines that you have for your cells in the clear glass if it's not on?
Any artifacts?
Yes.
If you look at it towards, if you look through the glass against a very bright light, you can try that out at the stand. You can see shades or interferential colors, or let's say shading of the electrodes and the segments. But there are different ways of basically fading them out, because we're talking about optical scopes, rangefinders, etc., and they will not accept any traces that are of a disturbance to the view. And we can do it better or worse, depending on the application. For a bus, the requirements aren't that high as they are for a scope. But yeah.
How are the displays powered?
They are actually low voltage DC is what our demos and our displays run on, 12, 24. What is in the glass is high voltage DC, around 120 to 160 volts.
Okay, thank you. Thank you so much.